Hello viewers, in today's session we are going to discuss another important problem from domain of functions. And here we have to find out the domain of this function f of x, which is equal to square root of x minus 2 plus 1 over x minus 3. Right? So here f of x is given as a sum of two functions. Right? So let us call this square root function as g of x, and this is a rational function, and we can call it as h of x, right? So f of x is the sum of square root function and a rational function. So in order to get the domain of this function f of x, what we will do, we'll first find out the domain of this function, that is square root of x minus 2. So let us call the domain of this function as d1, and then we'll find out the domain of this function, that is the rational function 1 over x minus 3, and let us call the domain of this function as d2. And then we'll find out, or we'll identify the common values of x which simultaneously satisfy this function f of x, and those common values of x are known as the domain of this function f of x, right? So let us call the domain of f of x as d. So d can be written as d1 intersection d2. So let us first individually find out the domain of the function x minus 2 and 1 over x minus 3. So now the function square root of x minus 2 is valid only when x minus 2 is either greater than 0 or equal to 0, right? So x minus 2 has to be positive or 0 in order to define this function g of x. Because if x minus 2 is negative, then this expression becomes a negative expression inside the square root sign, and in that case we'll get a complex number, and in that case the square root of a negative number does not belong to the set of real numbers, right? So for the validity of square root of x minus 2, this x minus 2 should be greater than or equal to 0. In other words, we can say that x should be greater than or equal to 2, right? So the domain of square root of x minus 2 is given by x greater than or equal to 2, which can also be written like this, that is 2 to infinity, right? So here this 2 is closed, it means 2 is included here. Now let us take up this rational function 1 over x minus 3, and here we are calling this as a rational function because a rational function is defined as the quotient of two polynomials, say p of x and q of x. So here one is p of x and x minus 3 is q of x, right? So the domain of this function is all real numbers except 3, because when we take x is equal to 3, then in the denominator we'll get 0, so this becomes 1 over 0, which is not defined, right? So the domain of this rational function is given by the set of all real numbers except 3, right? So now we have obtained the domain d1 and d2. So let us find out the intersection of d1 and d2 by making use of the concept of a real number line. So here we have the real number line, and this is minus infinity, and here we have plus infinity, right? So let us plot the points 2 and 3, and here we have 2 and here we have 3. So let us first represent d1. So d1 is from 2 to infinity. So we'll go like this. So this is the region which represents d1. So this is the domain d1, and remember here this 2 is included, right? Okay, now let us represent this domain d2. So d2 is r minus 3. So here we have the entire real number line, except here will not include 3, right? So first we'll go from minus infinity to 0, and then sorry, here we'll go from minus infinity to 3, and then from 3 to infinity. So this interval, or r minus 3, can also be written as minus infinity to 3 and union 3 to infinity, right? So here this circle signifies that 3 is not included, right? So here this 3 and this 3, they are not included. Okay, so now from d1 and d2, here we have d2, we have to now identify the common region, right? And from this real number line and the domains d1 and d2, we can easily identify the common region. So now the common region comprises of the interval that is from 2 to 3. First we'll go from this point, that is 2 to 3, right? 2 is included and 3 is not included, right? And this region, that is minus infinity to 2, is not included in d1, right? So we'll leave it, and then we'll take this interval, that is from 2 to 3. 2 is included and 3 is excluded, right? Because here 3 will make x minus 3 0, and 1 over 0 is not defined, right? And then we'll have here the union, and then we go from 3 to infinity. So then here we have the open interval. It implies that 3 is not included. So we'll go from 3 to infinity, right? So the intersection of d1 and d2 is given by this the union of these two intervals, right? So we can also write this expression in a compact form, and that is we can go straight away from 2 from 2 to infinity, and then we can write here a negative sign, and then we can exclude 3, right? Because 3 appears between 2 and infinity. So the domain of this function f of x is given by either this interval or this one.